So 18.5, this video we're going to talk about the first salt that we're going to prepare, which is soluble salt without Na+, K+, and NH4+. So when we prepare a soluble salt without Na+, K+, NH4+, we are using method 1, okay? Method 1 in general, okay, you're going to add some solid, okay, into acid and keep on stirring. Then you have the reaction, and then we'll have the salt solution. Okay, so let's have a look. Okay, what is the reaction? Say for example, this time, okay, we are going to prepare zinc sulfate. Before I move on to the second slide, okay, think about how many reactions it can form a salt which have zinc sulfate. Basically, there will be 3 kinds of reactions that will produce zinc sulfate. The first one, okay, that will be metal react with acid. So we have zinc directly add into acid and they will get zinc sulfate and hydrogen. But I don't like this one because you have a lot of bubbles and they are also flammable. So therefore I prefer not to use this method. Second one, that will be zinc oxide with dilute sulfuric acid. This one is a neutralization because you find that, okay, we have a base and also react with the acid. Okay, so in the process, okay, even that is solid, okay, we add it into the acid. Okay, the solid, even it cannot dissolve in water, but when it reacts with the acid, it still can be dissolved. Okay, and the third one will be reaction with zinc carbonate with dilute sulfuric acid. Again, okay, this one when you add into it, okay, you got carbon dioxide, you got bubbles to be seen. Okay, most of the time, okay, I preferred to use the second one. Okay, it will be easy for us to remember using metal oxide react with acid. Metal oxide react with acid is so useful because whenever what kind of salt you want to prepare, it can put the metal with the oxide and it must be reacting, okay, with an acid. But if you think about the first one, if you try to add metal with acid, some of the cases metal cannot react with acid. Say for example, if you want to prepare copper 2 sulfate, you try to have copper react with the H2SO4 or copper 2 oxide react with H2SO4, very obviously you will see that, okay, copper react with acid. This case is not feasible because copper is not reactive enough. So I highly recommend you to suggest a reaction which include metal oxide react with acid because it must be feasible all the time. Okay, but if you like have the metal carbonate, okay, then in the balancing you have like carbon dioxide, and sometimes maybe when you write the formula of zinc carbonate, okay, you'll get wrong with that. Okay, so I prefer to have metal oxide, which will be easier. So in the very first step, when you prepare the salt solutions, okay, you need to add excess, no matter it is metal oxide or metal carbonate. You imagine, okay, all these 3 actually they are not reacting with the water. Okay, they most of the time, okay, they will be insoluble in water. If you add excess in it, then they will remain undissolved and sink at the bottom, okay, of the solution. So you will see something like this. The excess one, okay, will be sink to the bottom. Okay, so why do we need to have excess zinc or zinc oxide or zinc carbonate added into it? So this one, okay, what you have a look, okay, what you think about that, okay, why have to be in excess? Okay, why have to be in excess? If it is not excess, that means which one will be in excess? The answer is the acid. So you think about like this in this case. If I have excess zinc oxide, then okay, all the acid can be react. So we will have zinc sulfate, which will be the salt, and then the excess zinc oxide will be the solid. If we have method to remove this zinc oxide, actually it's pretty easy. You just use filtration. Then in the solution, you're purely having zinc sulfate ions, zinc sulfate compounds only. But on the other way round, if the acid is in excess, then you will find that, okay, this time you are not only having zinc sulfate, but also you have some remaining sulfuric acid. In this case, if we boil off all the water, leaving behind, there should have two compounds in it. So therefore, okay, we don't want to have sulfuric acid to contaminate our salt. So therefore, we would like to make sure all the acid have been reacted. Okay, so you'll find that in this case, we'll add excess zinc oxide into it. How can I know that it will be in excess? If we see that, okay, there is some undissolved zinc oxide leaving at the bottom of the beaker, that means that it will be in excess already. Okay, so that will be in excess already. So sometimes, okay, we may need to heat it, okay, but heating up will help to dissolve more zinc oxide. The answer is no, because the amount of acid will decide how much zinc oxide, okay, will be rejected. Because the dilute sulfuric acid, okay, that will be the limited reagent. Okay, the limited reagent, okay, it will guide, okay, how much zinc oxide they have to react with. Okay, so therefore heating up, it just try to speed up the reaction between zinc oxide and dilute sulfuric acid. So after we all doing all these, okay, we have excess zinc oxide here. We ensure all the acid have been reacted. Then, okay, we will transfer this one, okay, into a filtration. We'll try to remove the excess zinc oxide. So in this case, you'll find that the residues, okay, you have to know that the residue, it will be the excess zinc oxide. And then the filtrate, that will be the zinc sulfate solution. Okay, so these steps, okay, we aim as filter the excess zinc oxide. Okay, and then, okay, next, okay, this filtrate will try to use a steam bath. You can see that this one, steam bath. The steam coming up will heat up the solutions, and bit by bit you'll find that in the process the water will be evaporate away. So when we boil that, okay, the solution will become more and more concentrate, and eventually they will become saturated. As long as we allow them to cool in the room condition, they will then form crystal. Okay, so you can see that, okay, after we boil off some of the water, make the solutions very, very concentrate. We just leave it there. We use filter paper to keep out the dust, so therefore extra or dust from the environments cannot come in to contaminate our sample. After we see some crystal form after a few days, we can filter, wash it, and dry it, okay, to obtain the crystal form. This crystal is zinc sulfate, which is the salt crystal. Okay, so the process involves filter off the crystal newly formed, wash. Okay, we have to wash it. Why do we need to wash it? Remember, water, okay, it just can able to wash away the soluble impurities. We don't want to have some impurities on the surface of zinc sulfate. So imagine we have zinc sulfate here. That will be the crystal. Okay, and on the surface, okay, you may have some soluble impurities. So say, for example, this one is soluble impurities. So we can use water to wash it away. Remember, water can only wash away the soluble one because the soluble impurities will go along with the water away. But the problem is we are using only a small amount of water to wash it only. Okay, can we use large volume to wash it? Okay, so remember the salt that we are preparing right now is a soluble salt. Soluble salt will be dissolved if you use a large amount of water to wash it. So remember, avoid using large volume of water to wash it. Okay. Finally, you got the crystal. They will be a little bit wet, so you may either use filter paper to wash it, to dry it, or you can use oven to dry it. So when will we use oven? When will we use filter paper? So of course, if you want it to be completely dry, no more water in it, we'll use oven. So the salt without any water in it, we call those anhydrous. Remember that? While the salt, may have some water of crystallizations in it, so we call those hydrated. If you just simply prepare a hydrated salt crystal, then you can use filter paper. If you want it to be completely dry, then oven have to be used. So mainly the process, that you have, it will involve several things. Add metal oxide into acid until in excess. Filter the excess metal oxide, boil to concentrate, cool to crystalline, and then filter, wash, and dry. These fields, we just have the keywords here. But when you write a paragraph form, remember you have to expand these wordings into a complete sentence. So just now we have quite a number of frequently asked questions. I've summarized them right here. So excess zinc oxide is to ensure all acid has been used up. Can heating help dissolve more metal oxide? No, it is just help to speed up the reaction. Amount of zinc oxide react depends on the amount of acid used, which is the limited reagent. How can we know that it is saturated? You can just dip a glass rod into the solution. If the dipped end of the glass rod turns cloudy very quickly after you take it out, it turns cloudy because we have some crystal form. It means the solution is saturated enough. So when you take out the rod, the liquid on the surface of it, very quickly you'll see that it turns cloudy. It turns cloudy because you have small crystal form in it, so therefore it won't be a clear solution. Then at that time I know that it's eager to be crystallized very quickly. Then we'll say that the solution is saturated. With fourth one, why do we need to wash the crystal form? Because we want to wash away the soluble impurities, and also can we use a large amount? Of course no, because we're preparing soluble salt, because large amount of salt will be dissolved and washed away. So these are the frequently asked questions. You have to know the design of the setup. So the procedures to write, so basically like what we've mentioned: add until excess, filter the excess, boil to concentrate, leave to cool and form crystal, filter the crystal formed, and wash with small amount of cold distilled water. Dry the crystal water with filter paper or oven. Depends on hydrated salt or anhydrous salt. So basically, you have sample, filter, wash, and dry. You have the separation method, boil and cool. And you have the reaction here. Reaction, separation, and purification. So remember, in essay type questions in public exam, you will have questions, something have a star in front of it. Let's say this is question number 4, and you see a star there. That means you have communication points right there. In order to have communication point, you should have no point form. That means that right now here, you will have mark deducted, or you won't get that bonus mark. Remember, never to have point form, but to teach you, I prefer to use point form. But when you write, no point form. No point form. Second, you have to remember you have to have complete sentence. No fragment of sentence, and try to, as far as possible, to put it in a paragraph. And also sometimes you may want to have equation or sketches to help you to explain. So summarize, we react to proceed soluble salt without Na plus K plus NH4 plus. The reaction that we have will include metal oxide, and metal carbonate react with the acid. But the one that I prefer will be metal oxide all the time. And second, the procedure to prepare, purified, and also separate the salt. And I forgot to remind you that we may need to sketch some of the setup, and normally not normally. For sure, in public exam, they won't ask you to draw more than one diagram to show the flow. That means that you won't draw picture A and then draw an arrow to write B and then C, something like that. Okay, if you draw something like that, you must get 0 mark. So normally, okay, the setup, okay, we may ask you to draw will be the filtration setup, like the one on the right hand side. So better spend some time to learn how to sketch a filtration and also label the things properly. Don't just label it as residue, but label what is those chemicals. Okay. So our frequently asked questions, okay, highly recommend you to remember the rationales about this experimental design and also some essay writing key points. Okay. So basically, okay, in shorts, you'll find that, okay, the paragraph, okay, you have to write, okay, involve these keywords: add excess metal oxide to the exit, filter off, boil to concentrate, cool to crystalline, filter, wash, and dry. So at the end, going to give you a QR code so you can have a look how the experiment is going to conduct in a lab. Okay, so scan the QR code and watch of it now. That's all for this video. Bye bye.